Hello, this is Bobby, Compatibility Repair, with a quick video at a customer. We do have a video already published on YouTube on how to test BN44-00618, which is what this board is. Come on. And this video is for customer Pierre S. Just to show that we are testing the board, that this is his board. It was lost for a while. My personal mistake, actually. I had it misplaced. So we have this dongle that starts up the board. This is the connector that shows what are the pins. This is the table that shows what are the pins on this connector. And the top left one is a standby pin. And as you can see, it has 5.2 volts there, standby voltage is there. When the connector is plugged in, the board turns on, the relay here clicks, and power factor corrector voltage, I'm sweeping the leads. This is positive, so the result will be negative. When the connector is in, the voltage on those capacitors jumps to 397 volts. 396, it doesn't, 396, 397. I'm pulling the connector out just to illustrate what will happen. This should start going down. Maybe not too fast, but eventually it will get down, and at some point the relay will click off. Okay, the board is not loaded, so this may take a while. Okay, but you can see it is going down, which doesn't prove a lot. The important thing is it will go down to 160. When this is plugged in, the board clicks. It basically tells it to start, which is, I don't know if you heard it, which is what the controlling boards in the TV tell the board. And when it starts, pull that back out and get it on the ground here. When it starts, it produces the output voltages. One of them is, per this table, D 5.3 volts should be 1, 2 on the third, and above 1, 2. Here is the third. The third hole is there. There should be more than that, though. There should be audio output 15 volts. There you go. 1, 2, 3, 4, and fifth from bottom. 1, 2, 3, 4 is 15 volts. We have that one too. VA is here, but it's not currently activated because it needs a separate signal, which is why we have a button here. And when I click that button, VA, the top two transformers, will start working here on the board. I am clicking the button, and here you go, 56 volts for VA. Similarly, this is where VS goes in the top, and I'm measuring that. I'll have some hard time clicking the button, but I'll manage to do it. So VS clicking is 220 volts. Measuring now. This is not, it is dropping because I have hard time maintaining the button pressed. This is not a 100% proper test of the board. In order to be 100%, all of those voltages should be measured with load, which I don't have the time to show. And to be honest, we are not measuring here unless we have to, meaning if a customer tells me that the board passes those tests and fails voltage under load, then I will test it, or like it is here. I will test the VS load. I will test the load is being measured according to this table here, which is by putting a resistor on each one of those, a load basically, not necessarily a resistor, but it's got to be active load is what I was searching for each one of those output voltages, so that we can see that the power board is able to withhold the according current that it's supposed to provide. Two are the most common problems there, and they're very rare. But it's possible this can happen on any board, and we will test that as well. The original problem with the board, again, the load problem is a really rare one. The problem with those boards is, in this case, I can see the power switches driving the transformers for the VAVS were burnt and they were replaced, which is why we test the board for problems that are related to that, and 1 in 100, maybe less, will have problems under load only. That's why we don't test and we don't make videos. Again, unless we have to, it's just not included in the price in our time schedule. Thank you.